Welcome to Future Human Science, where we delve into the most fascinating aspects of technology and science. Today, we're embarking on a journey into the world of artificial intelligence with a focus on machine learning. If you've ever wondered how machines learn from data and make predictions or decisions, you're in the right place. In this beginner's guide, we'll break down the basics of machine learning and explore how it works in an engaging and easy-to-understand way. Let's start with the basics. What is machine learning? At its core, machine learning is a subset of artificial intelligence, AI, that involves training computers to learn from data and improve their performance over time without being explicitly programmed for each specific task. Think of it as teaching a computer to recognize patterns and make decisions based on past experiences, much like how we humans learn from our experiences. Machine learning is inspired by the way humans learn. Just as we learn from examples and adjust our behavior based on new information, machine learning algorithms use data to learn and adapt. This process involves several key steps: collecting data, choosing a model, training the model, and making predictions. First, let's talk about data. Data is the foundation of machine learning. It consists of information that the algorithm will use to learn and make predictions. This data can come in various forms, such as numbers, text, images, or even audio. For example, if you want to train a machine learning model to recognize cats in photos, you would need a large data set of images labeled as cat or not cat. The more diverse and representative your data is, the better your model will perform. Once you have your data, the next step is choosing a model. A model is a mathematical representation of a process that can learn from data. There are many different types of models in machine learning, each suited to different types of tasks. For instance, linear regression models are used for predicting numerical values, while classification models are used for categorizing data into different classes. Neural networks, a type of model inspired by the human brain, are particularly powerful for tasks like image recognition and natural language processing. Training the model is the process where the magic happens. During training, the model learns from the data by adjusting its internal parameters to minimize errors in its predictions. This involves feeding the data into the model, allowing it to make predictions, and then comparing those predictions to the actual outcomes. The model uses algorithms to adjust its parameters and improve its accuracy based on these comparisons. This iterative process continues until the model reaches a satisfactory level of performance. Once the model is trained, it's time to put it to work and make predictions. In the cat image example, the trained model can now analyze new, unseen images and determine whether they contain a cat or not. The goal is for the model to generalize well from the training data to new data, meaning it should be able to make accurate predictions on data it hasn't encountered before. Let's dive a bit deeper into the different types of machine learning. There are three main categories: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning. In supervised learning, the algorithm is trained on labeled data, meaning each data point is associated with a correct output. The goal is for the model to learn a mapping from inputs to outputs. Common applications include spam email detection, where the model is trained on emails labeled as spam or not spam, and predictive analytics, where historical data is used to forecast future trends. Unsupervised learning. In unsupervised learning, the algorithm is trained on unlabeled data, meaning the data does not have predefined categories or outcomes. The goal is to identify patterns or structures within the data. Examples include clustering algorithms that group similar data points together and dimensionality reduction techniques that simplify complex data by reducing the number of features. Reinforcement learning. Reinforcement learning involves training an agent to make decisions by interacting with an environment. The agent receives feedback in the form of rewards or penalties based on its actions and learns to optimize its behavior to achieve the best outcomes. This type of learning is commonly used in areas like robotics, game playing, and autonomous vehicles. Machine learning has a wide range of applications in everyday life. For example, recommendation systems on streaming platforms like Netflix or Spotify use machine learning to suggest content based on your preferences and viewing history. Voice assistants like Siri and Alexa leverage machine learning for speech recognition and natural language understanding. Even social media platforms use machine learning to curate your feed and detect fake news. As exciting as machine learning is, it's important to be aware of some challenges and considerations. One challenge is ensuring the quality and fairness of the data used for training. Biased or incomplete data can lead to biased or inaccurate predictions. Additionally, interpretability is a concern. Understanding how complex models make decisions can be challenging. Researchers and practitioners are working on developing more transparent and explainable machine learning methods to address these issues. Looking ahead, the future of machine learning holds great promise. Advances in hardware, such as specialized processors and cloud computing, are enabling more powerful and efficient machine learning models. Innovations in algorithms and techniques are pushing the boundaries of what machines can learn and do. The integration of machine learning with other technologies, such as robotics and IoT, will lead to even more transformative applications. In conclusion, machine learning is a dynamic and rapidly evolving field that is reshaping the way we interact with technology. By teaching machines to learn from data and make informed decisions, we're unlocking new possibilities and solving complex problems. As we continue to advance in this field, it's important to stay curious and engaged with the latest developments. Thank you for joining us on this exploration of machine learning. If you found this beginner's guide helpful and want to learn more about the exciting world of AI, be sure to like, subscribe, and hit the bell icon so you never miss an update from future human science. Until next time, stay curious and keep exploring the cutting edge of technology with us.